Hi everyone, in this video we're looking at the introduction of ratios. Now you're going to be able to, by the end of this lesson, use ratios to express relationships between two values, because that's what a ratio is essentially. You're going to in order to be successful, you need to recognize that ratios can be used for different representations, so part to whole and part to part. And although ratios are different to fractions, they have very similar qualities in how we handle them and treat them. So a ratio is a way to compare quantities of the same kind, and they, as I said, they're similar but not the same. So we can write them in three different ways. We can write it as a fraction. So here we go. You've got like in words. So Miss Rakowski's class has 10 boys to 18 girls. How many? Yes. Or we can write it using like a symbol of colon. So that colon there represents this word two. So in this case here, we've got 3 circles, two rectangles, or sorry, 3 ovals. And then we can also use it to describe part-to-part relationships. So what I just said there was like circles to squares, or part to whole, so circles to 5 shapes. Or ovals, if we want to be correct here. In order, so your order does matter. So if I asked you the question, what is the ratio of rectangles to ovals, you're going to give it to me as 2 to 3, not 3 to 2, because the order does matter. So if I tell you I have a recipe for a cake and it's 2 cups of flour, 1 egg, 1 cup of water, milk, then you're going to give me the ratio of, like you say, flour, egg, and milk. It's going to be 2, 1, 1. So it's just making sure that you have the order right. Because if you gave it to me and you said 1, 1, 2, then my cake isn't going to come out because it's the wrong ratio quantities for each ingredient type. So order is always important. So here we go. We've got a question here. Looking at the completed game of noughts and crosses, write down the ratio of noughts to crosses. So count up your noughts, count up your crosses, and create a ratio. I've got noughts 1, 2, 3, 4. So that becomes the first number because order matters, and the crosses has to be 5 because there's 9. Now crosses to noughts is the other way around, 5 to 4, and crosses to the total number of spaces. So see how that it's a ratio, but now we're comparing to the whole. So it's going to be crosses, which is going to be 5 to 9. Total spaces to the number of noughts, order matters, 9 to 4. Noughts in the top row to crosses in the bottom row. So there's 1 nought in the top row, 2 crosses in the bottom row. What you can see here is that this gives you the hint of where the colon should be. So every time you see the word 2, that represents this little colon that I have put between my 2 numbers in my ratio. Now I'm going to write this one here as a statement of 7 millimeters to 1 centimeter. Now the trick here is, remember, a ratio is a representation of a relationship of values of the same kind. So in order for it to be the same kind, we need to do some sort of conversion, because millimeters are not the same as centimeters. There are 10 millimeters in 1 centimeter. So I'm going to convert this here to 7 millimeters to 10 millimeters. And that's my ratio. The order is still the same, and now they are in the same units. You'll notice though that I have not put millimeters and millimeters in here because ratios do not have units. The reason why they don't have units is because you are comparing the same kind. So see how it all links together. So what I'd like you to do now is, here are some questions for you. Pause the video, have a go at reading these questions. Again, looking for those words to, or there's that representation of a colon, order matters, write your ratios. Thanks, guys. All right, so in this part, we're going to look at simplifying the ratios. Just like fractions, equivalent ratios can be multiplied or divide to find a divide, but you need to do both sides of the ratio. So this is kind of like why they're similar to fractions. So in this case here, we have 16 to 24. It'd be like if you could do repeated 2's. So I'm going to go divide by 2, divide by 2, This is going to take us a while. 8 and 12 one more time, 4 and 6 one more time, 2 and 3. Or I can recognize that 8 is both a common factor in these here. Divide by 8, 8, and while I'm here, because I like to show you this pattern, 2 times 2 times 2 times 2, I think I said too many times, 2 times 2 times 2 gives us, so 2 to the power of 3 gives us 8. So that's why these two, how they link together, or how the pattern connects them, and that's going to give us 2 divided by, 2 to the 2, 2, 3. So again, when you simplify your ratios, and if you've been given units, you need to make sure that those values are in the same units. So I can see that this is meters and centimeters. I'm going to convert this one here to centimeters because it's going to give me a whole number. So 1 meter equals 100 centimeters. So I times this number by 100. So move your decimal 1, 2 places. So that gives us 150 centimeters. Now I can write them as a ratio, 150 to 45. I know that both of those, the common factor is going to be 5. So I'm going to divide them both by 5. And that is going to be 9. 15 divided by 5 is 3, 0. Oh, I can go one more. So it's going to be 3. And this one's going to be 10. Have I got that right? 30 divided by 3. And this one here is divided by 3. So I could have actually used 15 as my common factor. I should recognize that because there's a 15 there. All right, so that is simplifying ratios. So here you go. You've got a couple of questions here to get you started, and we'll do more about those converting of units in class. All right, thanks guys. Bye.